Alright, I think I have this figured out. As far as the audio goes, much better. Now, audio goes much better. Okay, good. So that's coming through good. Alright, so here's the deal. This is Veraldo 1.0 in its current state. This is now I did go into the main display shader and change one thing that was creating some artifacts. It was where I was not taking a sufficient number of steps along the rays and stuff. So you get weird artifacts anyway, so you're seeing a lot less of that now. I did have some cool screenshots from that, and I did actually kind of like that effect. But in essence, it's a higher fidelity, way to do it this way. So we're calling that good. Now, this mask by color, it's actually got some real potential here, seeding this with such a range. Because here we're setting by 0. Now, tell it, we want to use. Alright, we're going to go fully red. Okay. And the variation in red that's allowed is going to be like a quarter. Just real roughly. Anyway, whatever. So blue at 0 RGB, right? And we're going to allow the same amount of variation. Now, see what we're achieving by doing this? Two things. White, right, that's got a red value of 255. So we're going to be getting whites through some light grays. With the blue at 0, we're grabbing, from 0 up to a quarter of the range, which is 64. Anyway, so we're going to be getting the darker ranges. So we tell that go. Okay. Good, and just blow everything away. I'll use orange for some blur stuff later. Alright, so okay, that actually not what I intended, but it actually demonstrates exactly what the XOR texture is. Wow. Because that XOR texture is subdivided the way that it is. So, okay, not powers of 2. Let's just go ahead and reinitialize that. Okay, so yeah, so we're just gonna go ahead and we're gonna go more random than that. So yeah, we're gonna blow away everything. Orange. Okay. Okay. A little more interesting. So see these corners are rounded. That's from the fact that we used a non-power of 2 thing there. So some of these little bits of edge, like the edge, got, cool. So good. Now put a circle right at the center, sphere right at the center, radius 42. We're gonna go like that. Yeah. There you go, 2, 1. That's all I really want. Okay, and then 55, again 0, and because, you know, these only exist because they were masked before, we know that we can safely draw over top of that. It's not an issue. So blurring now, we have orange in all the negative space and blue in this center space. So my alpha blending is broken, but I actually kind of like it. So we're gonna have a toggle in here for how it's handled. I'm not sure exactly how I'm gonna change that. Interesting. Okay. Neat, very neat. Okay, yeah, so this is where you start getting some really cool behavior. When you have this blur, this interaction of like blurring and you know, some other different stuff going on. So we've got sort of blobby regions on the inside here. I'm gonna do this with a little more alpha. Yeah. Very nice. So again, now we're seeing individual voxels. We're not getting artifacting from like weird depth things. It's all just discrete voxels now. It looks, you know, better, I guess. Okay, so how do we want to do this? Yeah. Okay, so the height map thing where you're basically you've decided, all right, I want to draw something up from the bottom here, and that's based on, okay, black being lowest values, white being highest values, and so that height is considered, and then you draw this thing. This height scale tells you where you're going to put it in terms of considering this 0, whereas 1, you know, if 0 is black and white is 1, whereas 1 put is 1 here, is 1 here. I think by default it's about halfway up. But yeah, so just starting real low. Just make it kind of a medium red. Yeah, so this is a very low height scale. Go ahead and mask that. And then with a higher height scale, we'll do some sort of green. So it's the same height map except stretched out much further. It's all the way up there. And so that looks shitty. I'm gonna go ahead and let's see where we can get with this. I do like the blue auras here. This is cool. Let me grab by the blue channel and we'll see what we can do with that. It's probably, I don't know, we'll call it, yeah. It's too bad there's no color picker to the frame buffer. It's probably not that unreasonable to implement. I do need to figure out how to read the frame buffer in SDL, because that's pretty central to some of the selection schemes that I use. Okay. Let's see where that gets us. Okay. Interesting. Now, this load save is an operation that I need to implement. I think that's one of the central. So, actually, let me just go ahead through the list. There is shifting on X, Y, and Z, which basically means, okay, I have some X, some Y, some Z, whatever. I want to have this control available to shift all cells this way with a toggle to loop them around the edges. Okay, so basically all that means is yeah, so if it would disappear off this edge, do you just get blank space when you scoot this in? Is that filled with blank space? Or is that gonna roll over from this side? Is that gonna appear on this side and you're gonna have a little bit of slice of this side on that other side? That's basically that shader is gonna take an integer vector, 3 components, that's going to be you know, positive or negative on X, Y, and Z, and then a Boolean toggle for that looping behavior. So I think with that, that'd be cool, because if you think about it, all right, I'll scoot it this way. Okay, I can chop it off to like maybe like this level. All right, well then, okay, that's over here now. Well then I scoot it back this way. I can chop it off to the other side like this, and then I have this thing that's like a quarter of the width, and I have like this slice. Not quite like the slice viewer that I had in VO7, the one that that was actually because the rendering method used a bunch of like square slices. This rendering method is different. It's a raycast thing per pixel. Let's see. Honestly, I think this one might be, you know, we call it quits on that. Now, all right, let me finish going through that list. Load save is a big one. The shifting X, Y, Z. I want to add another primitive to do grids across the whole thing. Configurable spacing, thickness of the lines. then an offset also. So very similar to what GIMP does with their legacy grid tool. Lighting. Now, I have written down point light, but the real key ones are, okay, one utility function is the lighting buffer clear. That all that is just clearing the lighting buffer. I mean, it's literally all it is. That's just a function implemented as a compute shader that resets the values in the lighting buffer. Then the directional light, that's basically going through and when you've got like you're gonna establish some origin point and then in a very similar way to how you do the display function currently, where I'm shooting a bunch of rays into the scene. That's a very similar operation is going to be, that's what takes place to do the lighting. But it takes into consideration the alpha value of each cell that it goes through and decreases the intensity of the lighting that it's applying. And so by doing that, you end up with these, like God rays, sun shafts, you call them different things maybe. In essence, volumetric lighting effects. That's something I really want to implement in this. I have done it in the offline version. It was a CPU thing, and computing everything per frame was like a minute or something. It was stupid. But with the compute shader thing, I mean, we're at a steady 60 frames a second, and let me just actually real quick while I'm thinking of it, I think this will be interesting to see what kind of frame rate we can actually get out of it. Let's see. Let's go ahead and put this on the screen. So where would that be? Basically what we want to do is what do we want to do? With the compute shader, I mean, we're at a steady 60 frames a second. Oh, right, turning up the frames per second limiter. So that's going to be in I need to refamiliarize myself with this because I need to implement a few more features. So let's say utils probably. We'll get that. That's all I could for now. Okay, so create a window. Yep, here we go. So, whatever. Yeah. A lot of errors in this, but yeah, so yeah, 5 milliseconds to do everything. Curious. Okay. Let's see. Yeah. Is that right? That's right, yeah. So 165 is the number of steps I had to find from before. And I upped it to 500. And that's where we're getting that smoothness. I'm gonna go ahead and open this up. That doesn't actually require me. Because it's all compiled at runtime. Okay. So, yeah. With that, okay, yeah. We're talking about something that's crazy efficient. Whatever. So, you see, we're getting these artifacts here. That's what I was talking about with that step size. I could go smaller. Now, that's heating up the GPU, doing it like that. But anyway, you get the point. On the order of a millisecond and a half, 2 milliseconds, 2.5 milliseconds. Nice. So basically, I'm gonna go ahead and put that back the way it was. And actually, the other one too. What is it? I guess. Whatever. I think that's got us where we want to be. Okay, so ambient occlusion. Okay, that's another of the lighting functions. The static lighting, that's the directional lighting. Point being that there's two functions here. There's the lighting clear, that's one compute shader, distinct from all the others. And then there's static lighting, which is launched the same. Okay, I'm gonna have to figure out how we want to launch that in terms of workgroup size, stuff like that. Because it's not going to be per voxel, it's going to be a square grid, two-dimensional kind of problem that we're trying to solve there. Game of life compute, wire world compute, relatively simple, just encoding the rules of those things. Yeah. I'm not gonna go through the all code here. I don't find any use in setting this up with you know, with the vsync off. It runs smoother. It doesn't saturate your resources here. You know, well, smoother, I guess, whatever, but yeah, so you're only dispatching this once every, you know, whatever amount of time to get that 16 millisecond update. What else? Okay, I mean, I can do some other little stuff here. Take a look at what if we go through here with the cylinder first? Okay. Okay. Oops. Not as intended, but it'll be interesting. Yeah, what the fuck ever, I mean, shit. I can go with that. Okay, and again, what I'm doing here is drawing with completely clear, but the other 3 channels are set, right? So alpha being set to 0, but the other color channels are set. So when you do your neighborhood averaging to do your to do everything to do the blur operation, then you're looking at you'll be seeing those colors. So we'll go ahead and do yeah. Actually, let's go ahead and do let's get all the light red, so all the light colors to 197. Right, so that's about 0.2 of this. So I don't know. We'll see where exactly that lands us, but it's going to be some chunk of the lighter colors is going to be masked. So parts like this, that's where you're not going to see any blurring. So tell it to respect the mask. I don't remember how I implemented the touching alpha. Here we go. Yeah, so that shows how we're respecting the mask there. Oh, that got masked. Okay, well, it's... What if I did a dilate mask? an operation to expand the masked cells outwards one cell in every direction. Because I think that might have some real potential. Now, what if... Well, I guess we can just do this. Like my orange. So there's that. We're just gonna go ahead and blur. No respect for anything. Okay. Let's go ahead and grab from minimum edges. Yeah, we're gonna grab like that much. Okay, cool. Right. And so that's just using this access line bounding box primitive, which is basically saying, all right, I have these x, y, and z axes that define this space, right? They're the unit vectors, whatever. I want to draw some shape that goes from some minimum to some maximum along the x-axis, y-axis, and z-axis. So that defines some sort of cubic type region, not a cube, whatever. It's a, whatever sort of shape you want to call it. But I can range it, right, and be looking at expanding, right, because I'm this much along this axis, and then this much along that axis, whatever. In the same, you can see what it is vertically. But here, I don't know. I think it'd be really cool to be able to save stuff because, well, I'm not sure exactly how to do manipulation. I think copy and paste is something down the line. We need to figure out some sort of cursor type operation before I can do that. That I really should consider though, because being able to, because I really like this flare right here. What if I could take that flare, I really like how that curvature happens with the blur. Okay, say I wanted to kind of try and grab like this much of this piece and use it to build something else or whatever. That's kind of the angle that I'd like to try and support with this. And also stuff like the lighting. I think the lighting is really, really cool. Right now, initializing the lighting buffer with a neutral value. We're calling that. I want to say it's 0.5. I don't remember exactly how I'm doing it. I need to look at that code again. But basically, there is a lighting buffer implemented. I had it implemented where it was seeded with Perlin noise before, but that just gives you like a weird discoloration across the cube that you don't really. I mean, the user doesn't have any real knowledge of like what's going on there, so it just kind of looks silly. It looks like there's something wrong. But yeah. Let's take a look at this. This one kind of got shitty. Let's do. Let's do just a tiny little bit. Well, let's think about this. How do we want to do this? Okay. It's not bad. Alright, let's try it this way. Interesting. These look like bilinear texture filtering artifacts. I guess that neighborhood averaging thing is a very similar operation. Like they get arbitrarily shitty. Let's see. What do I want to do here? Let's go ahead and just blur this, but not that wide. We'll go 2. Whatever. Okay. Now, alright, so effectively I can get that slicing behavior with my axis aligned bounding boxes. Now, or the shifting behavior, whatever, I can get something similar to what I was suggesting before. Right, but the gist being that I want to have a more flexible tool that you can approach these things from a different direction. And I find that that's actually really interesting because here, when you see this this buffer, you can manipulate it in all sorts of damn ways at this point. I mean, shit, I have a bunch of different tools, a bunch of different shapes you can draw into it with. This is getting to be a kind of a cool little program. I need to work on, I mean, at some point, making this more maintainable for myself. It's just really not super functional the way I have it right now. Okay, so I'm going to mask that region without drawing. And then I'm going to draw over the rest of the region so that I can basically just cut it down to that region that was inside of that first bounding box that I established. Let's go ahead and take a look at that. Actually, yeah, let's go ahead and do this. We take the draw menu, we're going to go ahead and do Perlin noise. Yeah, we'll just start punching some holes in that shit. Yeah. Okay, not very tolerant to zooming in. My renderer is apparently. It does not scale well performance-wise. So anyway, there's some editing potential. Now, let's say. Okay, here's a cool way to use the masking functions. Go ahead and unmask everything. Now, we'll use the alpha channel. We'll go for a large variance from 255, right? And that means we're going to be grabbing most of the, well, you know, actually, we should actually go probably pretty wide on that, because we just don't want it all the way to 0, right? If it's at this, then we're going to be grabbing everything at 0. So we'll call it, you know, somewhere in the low 0.9 range, whatever, like that. We mask based on that criteria. Then we go ahead, and so we've masked everything that has a high enough alpha value to fit that. So then we're going to go ahead and do, okay, and that kind of shows you what was masked in that white region. You know, what's not changed inside of the white region. So it didn't quite grab everything. But yeah, you can see individual voxels here and fewer artifacts, I guess. You're really only seeing the discrete edges of the voxels for the most part. And so yeah, that's I don't know. I think this is really, really fascinating, and to have it real time, interactive. You know, I really dig this this type of interaction, because once you understand the tools just a little bit, most of them are very easy to use. This one is not. But it's potentially something, I don't know, like with machine learning stuff. This seems to be a very, very powerful shape. If you wanted to kind of like discretize a volume of a sort, I don't know, something that was defined by a mesh or something like. I don't really know exactly how you would even start setting something like that up, but basically my thinking being that if you have something that can establish these or you can reinforce or enforce whatever these parameters that you know, A, E, G, and C all need to be in a plane with one another. Otherwise, this shape is ambiguous. Because doing that manually is a pain in the ass, and I don't know. It's kind of a hard thing to give. You know, what you see is what you get kind of control over that, because it's not. I don't know. It's just not an easy interface to establish there. So yeah, I don't know. I do really like this program. Like, I don't know. This has really kind of been my baby for a number of years at this point, and to have it at this level of development really, I mean, it feels like some level of achievement anyway. Yeah, so I really quite excited about the potential of using the GPU for different stuff. Currently, I have a project in the works that takes this raycast voxel type display and adds some interesting simulation elements to it. I found some. It was an interesting sort of a thing this fellow was working on to. In essence, he wanted to simulate an ant colony. So for all the cells in a grid, a two-dimensional grid in his case, you had some pheromone concentration. And I need to look at exactly how that pheromone concentration was implemented, but I was thinking at least part of it is like a diffusing thing, which is like a neighborhood averaging. And so we can look at something like that. And I don't know, all this stuff, it's so practical to do things in real time now. I mean, crap, you look at everything I've been able to do with compute shaders in this project. I mean, I can touch every single one of these 16 million voxels in, like, you know, a small enough period of time that you're not noticing how much time passed, right? Those operations are effectively immediate. You know, even the wider neighborhood blurring on this machine, well, this is dependent on this machine. You do this wider radius blur on my laptop, it will hang for as much as like a quarter or half of a second. But I mean, you say a quarter or a half of a second, I mean, Jesus Christ. I mean, you look at the size of the problem here, that's an enormous amount of data to crunch. And you know, you're just, oop, you know, like nothing, right? And I can just keep doing it. And I have these averaged out, you know, values in the thing here. So, you know, I think this stuff is incredibly interesting. I think the load save operation is a really big one, especially because, you know, be able to grab like some of these contours in here and use them for something else. And I think copy paste I hadn't considered before sitting down and doing this just now. But I do think that that's a solid idea. Now let's just go ahead and do Perlin noise. Yeah. Yeah, so, you know, I like that all those operations sort of have, is deterministic the right word? I'm not sure if deterministic is the right word, but regardless of the state of the board, there is a defined operation, like I just drew it that Perlin noise. It doesn't give a shit what the history of this thing has been. I mean, you look at the mask value, you look at the color value, you make your decisions, you draw the thing. It's as complicated as it gets. Like the logic's very simple, but you know, really, what this hinges on is the hardware accelerated nature of the, you know, putting everything on the GPU and being able to do this all in parallel. I want to do something with this Perlin noise. Okay, so we're gonna get cool. Right, and then we need to use the red channel, I think. Yeah, try and just get the higher values of that. And if it doesn't look good, I mean, what the hell? Who gives a shit? We'll just start over. And I don't know. I just this volumetric representation is really cool to me. I don't know. One of the big angles for that pheromone. I don't know if I described it in those terms, but it's simulating an ant colony in the way that they communicate with pheromones. Basically, they're using image buffers to simulate this dispersion of this pheromone chemical to tell ants. This act as a signaling thing for all the you know, the ants, I guess. Yeah, I want to try and do Boids as well. And from what I understand, there's some grid-based optimizations that I could implement with another, you know, one of these types of buffers. Yeah, basically what that is it's a flocking behavior simulation. Basically, what I would do is I would have another shader that runs per one of my simulation elements there. Right, so per bird, whatever. I would have that be something that I could, you know, it would be launched as a shader, you know, per each one of those. And then basically two things it needs to do. It needs to update the position, which is a couple of state variables that are held. Position and also potentially like changing some state variables. But that's all going to happen in something like a vertex shader or something like that. Basically, like there's a static geometry buffer that's the ground and the buildings and whatever, and that's used as part of the simulation as well. But at runtime, you've got a second buffer that is drawn to by the shader that handles, per simulation element. Right, so that's doing double duty. That's updating the position, then that's putting a pixel onto the display buffer that then gets raycast for for the later on the display operation, right? So I'm thinking just like little creatures that rove around on like the surface of things. So just moving around on relatively flat ground, maybe the idea. Implement that logic to be very simple. Something like I want to have like a pheromone that attracts them to like some underground resource that they dig to. Maybe stretching what you are understanding as, the physical reality there, and just kind of extending it to this is some buffer that allows for this type of attraction, right? You can kind of, I don't know, start to generalize it away from, being pheromone or whatever. It's just an interesting way to cache the, because to cache the direction you want to go in. Basically, what I'm thinking here is like, as that diffuses out from the source, right, it naturally creates a gradient that increases as you go back to that source, right? Just because if you average it out and out and out and out, it's becoming thinner and thinner and thinner. It's like the inverse square law, except on a discrete grid. It's being, it's not, inverse square law might not be the greatest way to just describe it, but that's that diffusion principle that where it's becoming less and less concentrated as it goes out. So my understanding, anyway, at least to some extent, of what's going on with this thing is you take advantage of that that gradient, and you're using that, at least to some extent, for navigation. There's some other simulations that approach that in some different sorts of ways, but it's step by step here. Let's see. Yeah, so I think having some simulation elements in voxel space that are handled by GPU processes, I think it's a really neat angle. Definitely constitutes a cool project. Something I could definitely write up and have some worthwhile discussion about. And I mean, GPU-driven simulation for a real-time application. I mean, that's a really neat little package. I really think that that's a good angle, and I think I'm gonna trying to get something together with that. At least a prototype of what I want to do with the display. It's sort of kind of based on this Raycast thing. I'm gonna try and get that done this week. So if you can imagine constraining this voxel space to a sphere at the center here. I'm gonna have one view that's like that, and I'm gonna be rendering to a texture at a much lower resolution. So it's like a, maybe a quarter of this window size. But okay, so in essence, what's going on there is we're doing this raycasting operation. And if it's inside of the sphere or whatever, it's going to be fair game for raycasting. So you're going to get this like crystal ball sort of, I don't know how to describe it, snow globe kind of effect to it. That's kind of what I'm aiming for anyway. Getting some interesting artifacts here. I'm not really sure what that's about. I think I switched back to the old rendering scheme with the different number of steps. I'm not 100% sure about that. I'll have to take a look at it. But in any event, yeah, so I'm thinking low resolution, raycast like this. So that's a much lighter process when you're doing it at a lower resolution. Fewer pixels to worry about. Then what I'm thinking from there is you've got a second view that's like a cylinder, and in essence this cylinder view is kind of like zoomable, right? So you would think of it as like a map view. Right, so if you hit your map button, you go from your close-up, local view of what's going on around your character in this spherical volumetric thing. You then go to some wider view that's a voxel space constrained to a cylinder that you're able to zoom in or out and kind of like get a sense of what that all looks like. Now, here's another application for copy paste. It's things like this. Signed distance fields are a thing, and I mean that might be an interesting layout tool to grab chunks of these grayscale, the blurred grayscale type of things, and see where you can get trying to do discrete SDFs like that. I've seen some really good results with bitmap signed distance fields. Some people have done some really cool stuff with that. I haven't really done much with it. This isn't really an SDF. There is a representation of the geometry that's set against the ray per pixel on the screen. So it's really not that dissimilar, but I get two exact values for the intersection points with that ray and this cube shape right? And I'm defining the space where that ray is coming in and testing against this cube or whatever. Basically, the way it's defined is like I get a t min and t max, and that's origin plus t times direction, right? So direction is a unit vector along the direction. So t times that at the minimum, t min is here, and t max is the maximum value of that parameter t that has you intersecting at that farther point. So with the display function, basically what you're doing is you're compositing backwards. You start at this far point and you're adding all these together up to your display. So when you see this clear yellow, it's actually being composited forward to your eye, starting at the back and coming to the front. And that's just the nature of how that's being handled, because I have to be able to handle arbitrary contents inside of this block. Now, I think this is I don't know. I mean, this is I don't know. There's so many limitations in place on this. I think it opens up quite a bit with some sort of solid copy paste system, some sort of, and maybe if the copy paste system respected the mask in some way. I'm really not sure how I would want to handle that. That's almost an entire project by itself. I needed to design a more scalable interface for this. I went and put together that whole interface for, I think, VO5. I don't remember, but I really spent some time designing how all the pieces interacted with one another. I think I need to go through and do that again, because this project kind of grew to be large. This is a big project, and it really has kind of defined feature creep in a lot of ways. It really is. I don't know. There are big parts that I need to finish that are left unimplemented. Like, I think it's really key that I get. I don't know, the directional lighting at a very minimum. I want to have that finished before I show this to anybody, really. Ambient occlusion, it's basically, it's very, very similar logic to the blurring function. Not exactly the same, but it's similar logic in terms of what you're doing with the data. Lighting buffer clear, totally trivial. It's just all the formatting around doing that totally trivial operation. I think that's one of the key points is you've got the menu item, okay? So you got the function call that's got a whole bunch of parameters, all right? You got all the uniforms to set up to go into the shader. You got the shader itself, which you've got to set up with all the buffers and stuff, so it's got access to all that. So you got to add in a separate spot where it's compiling compiling the shader source. Now, some things that I've seen done, they treat it as a string. They have some standard set of data that they're establishing that interface, right? And that's kept as a string. Then you add some center bit of logic that that's the body of your thing, right? So then you start handling your programs just as like composited strings. right? That's one way to do it, and I think that that's certainly valid. I just haven't implemented it in that way. It gives you a huge amount of flexibility, and you can start looking at things like node editors and things like that. That's complicated, but realistically, it's not unheard of to. I don't know. You can come up with some sort of color-based selection scheme. Unique identifiers for each node based on color. You click on one, you get that color back as a sample. I mean, shit. These are things that scale well. That's something where you have a lot of nodes without a lot of problem. Even if you limit it to some smaller palette. Now I need to actually figure that specific problem out because colors don't always 100% match, or maybe you need to be more precise in how you're specifying them. I don't know. I was having some trouble with the chess game, and I think that's one of the things I had a run-in with JavaScript because I was putting together a couple things for my website, some little JavaScript demos. I absolutely hate the way JavaScript treats types. It's just, why would you ever want to, declare, a type of a different precision? I mean, shit, who would ever want to do that? That's the thing is like, I do want to do that because I have specific reasons to do that. And so using their, whatever goofy logic for whatever they're doing, it's I don't know, it's just I really don't like it. I have a lot more luck with C++ where I can say, all right, this value is fucking 8 bits. I know what that means in terms of the potential range of the values, 0 to 255. All right, that's solid. I can get behavior I can depend on out of that or whatever. It's just so much more functional to handle it that way. It's not even funny. So, I don't know. Like, there's a lot that you can do even with this program in its current state. Like, I really dig that. I think that's really cool. The height map, cutting into stuff. And then, you could come in here a little bit less. I don't like how Windows is able to turn on your computer now. Like, just whenever they feel like it. This really seems not great. Oh, that's the corner of the sphere was there. I was wondering what that was. Yeah. Well, yeah. So, say I want to go in here and then, yeah. Yeah, that's kind of a little bit sloppy with it. Let's see what this looks like. That's interesting. Huh. I love the sort of blurred artifacts that you get out of these, a lot of these, like this. See now, again, I'm just again and again seeing applications for this copy paste operation. Maybe some sort of sprite sheet kind of thing. I really don't know. If you have like a clipboard, I don't know what the best way to implement that would be. Well, I guess it would have to be another buffer that's at least the same size that you could take pixels into, pixels, voxels into. That seems reasonable. This may be a new iteration of this project. I need to do the write-up on what I have on this one, and I need to call it finished, and I need to, I don't know, this is because I can re-implement this. I know how to do this now, I've done this. And I think that's a really cool thing. Like, I put this together all myself, and I know that I can do this. I think that's been really key for me to figure out what I want to try and do here is to see what I am able to do. And see that realized in a like a way that comes together and actually is a finished product. To whatever extent that it actually is. This I don't know. This may be a thing where I want to just go ahead and do, Veraldo 1.2 or whatever, 1.1, call it, and try and clean up the menu. I don't know, think about that interface better, because look at this fucking thing. Right, you got, everything just kind of slapped in here. That's not great. Mask stuff, this is okay. This sucks. That should be at this level. You just click that, right? Instead of clicking that and then that. Right, well, and the same thing here. This bears having a thing pop up for it. This isn't implemented. This isn't implemented. This isn't implemented. So this is really key. Copy paste would be big. I need to think more about every single operation that would be supported. Really try and get it in I think this requires another iteration, honestly. It's like 90% of the way there, but it's like, I don't know. I'm so torn on this one because it's like, I don't know. It is just a couple more things to implement, but it is such a pain in the ass to implement them in this schema, because it requires changes in like 6 different places. That's not true. It's like, it's seriously at least 4 places. No. Because you've got, alright, your shader compilation, you got your function to call the compute shader, you got, the prototype for that. That's 3 places already. You have the menu entry, you have like a couple other things associated with the menu entry that are sort of like state handling things, so that you know like what up a level means. So if you're in the draw menu, like all these are considered as part of the draw menu. So there's like a place where I had to like group all this together so that I know that like the level above it is main menu or whatever. And if I go to sphere, like I can go back up to the draw menu, or that's not right. But I know that back goes back up to the draw menu in any event. So, like, I don't know. That seems like you're talking about a pretty reasonable size undertaking to go ahead and redo all this. This is honestly, I think this is the biggest single project I've ever actually worked on. And also the biggest individual project I've ever worked on, I guess. It's an individual project. The concepts we're dealing with are really, really neat. It's I don't know, it's something where you need to describe what the implications are, because not everybody's going to understand what a compute shader is, and they're not going to understand how many voxels are inside of this block. I'm not going to understand what it means to be able to, go through there and say, alright, for every single one of these fucking voxels, is that fucker, is that, for every voxel, is this triangle gonna be inside that, or is that voxel inside of that fucker? What's going on? Oh yeah, the thickness. Yeah, so for every voxel on that thing, now, what do you see there? You can change these things, but I don't know. You can make a mesh out of triangles, and having a triangle as a primitive is really fucking powerful. Like, just really, really powerful. I don't know. It's a whole thing. It's I don't know. I need to finish the write-ups on my website about this project and about the three-dimensional soft bodies. Let me go over that really quick, because when I went over it previously, I had some really bad audio issues, so yeah, so this came out really well, I think. This is I can get the parameters set this way. I really like this rear quarter view. On this driver implementation, I'm getting way more clipping on the lines, and I'm not exactly sure what that's about, but it is what it is. Because on the other machine, it wasn't something I was seeing at all. See, I'm getting a little bit of this like flickering sort of behavior, just fragments trying to clip through each other and stuff. But yeah, so tension coloring, red what is it? Red for compression, blue for tension, I think it is. Anyway, you can do different things with the simulation. You slow down the time step, change gravity values. You can scale the noise that's displacing the wheels. You can really screw with it. And also, because this is DRM GUI, you can just control click on it and enter yourself a value. So if you want to go, 6 and really screw up the thing, that's totally within the realm of your capabilities here. Your noise speed is very similar to your noise scale, except it's the other dimension that you can, right? So up and down, and then the other one's like how quickly does it go, the XY offset into that Perlin noise space. So I'll just go ahead and reset this because it fucked up really bad. So you can screw with it to get some decent simulation parameters. Have it looking at least how you want it. Turn this down. Turn this up. What's going on? I think we're gonna start that over. I'm not sure which. Not sure what was screwing that up. Anyway, so we can set chassis spring and damp constants, and that's all these green links, right? So I can set that to be a much higher spring constant, and it'll explode and everything will fuck up. But I can turn that way down, and then these are not springy at all, really. Yeah, so I guess there's not a huge amount of freedom in the chassis links. But yeah, things like the damping, you have some stuff you can screw with. So you can change with the spring rates for the suspension, and you can kind of see how that changes the behavior of the wheel wells here. This is the shock links that this is affecting. So you add more damping to the suspension, you see the body moves maybe a little bit less. And so this is where you see the noise scale starts to make more sense, because you can start to look at greater displacement, and then you can look at changing the physical parameters to try and match that to what you want the behavior to be. I don't know, this isn't very general. Now, to try and make this into a car game, this is something I've really thought a lot about. I'm not really sure how you want to handle it. Because these are just 4 points in a 2D plane that are sampling Perlin noise, right? And they're sampling the same way that all the orange points on this plane are sampling. They're sampling the exact same way, just at the wheel positions, right? So it's setting the wheel height. So this is not, I mean, really, that part of it is really cheating. The rest of it is based on those positions. So, it's all based on a lie, right? There's no physical simulation of like where the wheels are. This is, it's just like a graph of energy propagating out from like energy that you would be getting from the wheels hitting this thing at the points where the wheels attach to the suspension, right? So this is this is what you're looking at. You see the suspension links and you see the chassis links, and you see how when this energy comes in, this bounces upwards, that propagates outwards to all these other links. I mean, there is a full soft body simulation going on here. And this is all calculated on the CPU with double precision floating point numbers. And I'm doing that. I don't know how key that really is to getting good results here, but I do get the sense that I have greater stability when I use double precision versus single precision. That's, I don't know, maybe opinion, whatever. Not opinion. It's a huge amount more precision. It's just whether or not that's worth anything. I really don't know, because you start to see this instability when you change your time step to something that's, you know, outside of whatever is reasonable. I don't know what's reasonable or why. I'm not sure which. You start to see this instability. I'm not really sure which part of the calculation is causing this to be an issue, but it really gets unstable, and you start seeing these things where it's like you know, it just explodes. It's you know, it's a situation where some forces are not being calculated correctly, and then that just, you know, it's just untenable to try and do anything with that. So that's pretty much all that project is. That's I want to do some like bridge trusses with this same engine, because all that entails is basically changing out the points that I use for this simulation. I could even use the same same logic for the anchor points. As far as jiggling them up and down, I could just attach a bridge truss in between, and just have that as a something that jiggles around, and you see how it how the internal structures would work. Let's see what else. Let's go through and I think, yeah, this one, I don't know, this is something that I always really thought was cool. This is V07. This is a different way of handling voxels entirely. Basically, I have this thing that's like a, I don't know, it's like a rectangular prism that's made out of slices. These slices look like this, like that white outline. And so as I pass that through there, it's highlighting each individual slice through the thing, and you can kind of see the white highlight on the current slice. So this is a little bit cheating, and this is still using OpenGL geometry and doing the alpha testing per slice. But yeah, so some cool interaction that you can get by just highlighting just things that are within a certain width of that slice, forwards and back. And so you can explore kind of what's more local to something rather than having to look at the whole thing. And that's segmentation is kind of the big thing with this, is that, like, all right, that's a block of color. Like, I can't really very well see the inside very reliably. So ways to kind of get in there is that's something that's kind of key. You know, that's like, I don't know. I think the stream just died. Okay. No, it's good. All right. Very good. So, I don't know, the chess program works correctly on this one, so it's not interesting. Yeah, that's pretty much it. The spring mass damper, that's the 2D implementation. That's this thing. So you can apply this, like, you can see how this is the same as that, well, nearly the same as the 3D model that I put together. I used Blender, and I used the similar source material that I used for this, except obviously that's a much more complicated model, being three-dimensional with all the sort of three-dimensional truss sort of stuff in there. This one is pretty cool. I like this one a lot, because it's got a lot of structure to it, and it really shows the tension and compression here. So you've got the compression in red, tension in blue, and you see how it settles. I really dig that one. So this one is some cloth. It's not very good cloth, it's just cloth. I don't know. It's just a grid of nodes that are interconnected. But you can see as a network how the forces propagate outwards from, messing with one of them. So, yeah, I think that's that. Let's see. I don't know if well, okay, we'll get over texture. This is kind of the basis for what is in the works right now. So this is the initial thing, right? You've got your 3 good guys, 3 bad guys, 3 trees, 3 boxes. I click, everybody moves towards the box, somebody captures the box. Okay, capture a point, okay, blah blah blah, good guys captured, bad guys captured. Okay, game over with score equals 2. Okay, so that's kind of the general structure. Getting a lot of seg faults on this machine. I'm not really sure what's going on with that. What fast bends is. Anyway, so where the real configurability comes in is the fact that you can change the number of these different things that you have as part of this simulation or whatever. So if I go really, really dense on just make sure this is working. Can't actually tell if that's running or not. So all right, whatever. Anyway, so you can watch it for a little bit and see how they diffuse off the edge, and when they do, they'll reappear right at the center. So you see that one just disappeared, reappeared right at the center. So they start to concentrate maybe a little bit at the center. But so I've given myself a number of boxes so that I can direct the behavior. I have a number of chances to do that. So as I place each box, everybody moves towards the box, right? Because that's kind of the motivating behavior, is score a point for your team by capturing a box. Now, as you can already kind of start to see, getting some interesting behavior around the trees and stuff, because these groups and stuff, they'll start to leave like wakes around the trees because there's some behavior in their navigation. There's some code in their navigation behavior that gives them that sort of almost physical interaction with the space. Yeah, so you can kind of, yeah, just like that. You can see where that's more of an element. And yeah, so this is all single-threaded CPU updates for the guys. There's about 1,000 of them, and that's like viable for real time. You know, there's various different ways that you could speed that way the hell up. Thread it. You know, try and do this with some sort of GPU process, which realistically, I think you could do. I've liked thinking about ways that I can implement things with GPU resources. Recently, I think that the pheromone structure is a really interesting idea, because it's like you're using image buffers as kind of like you're caching like the result of, you know, it's not like quite a result, but it's like a partial result to some computation, but it's like based on the space more than anything else. It's I don't know, it's a really interesting little scheme. But yeah, so again, you can see the flowing around behavior there. Yeah, I don't know, I really like the graphics for this one. It's the simple spheres. That's all one texture. That's a little sphere. And it's got some fakey sort of lighting on it. The yeah, so a couple ways to spruce this up would be to add lighting on the thing, or to, you know, I don't know, there's various different things you do. So key thing, Vertexture 2, as I'm calling it right now, doesn't really have a huge amount to do with this project, except for that it sort of has these autonomous little dudes, and that is what they're called in this in the code in this project. They're dudes. The dudes and trees model is the name of the class that handles the trees and the dudes. And the reason that they're handled together is because the movement is so closely linked to, like, it's, I don't know, it's all just handled together. It's for simplicity's sake. And this was something I put together during a school year. So it was kind of slapped together. Realistically, it was I don't know. If I did something like this again now, I'd have more time to go through and fiddle with it. But honestly, doing it under pressure like that, I ended up with a really good result, I think. And I don't know, I mean, I haven't touched it either, so, you know, it's something that scales to this point. That was something key that I built in really early, was that, you know, design it, you know, with that, you know, the default parameters 3333, but like, what the hell did I use here? I my numbers are 450 good guys, 300 bad guys, 75 trees, and 30 boxes. So something that scales really well to that. Rises to the occasion. Whatever. I'm calling this machine VCR. Very cool rig. I don't know. Whatever. That's not what it's for. It's because the case of the machine looks like it's like the size of a VCR, but then it's got a heat sink popping out the top of it like a big a big supercharger on a car hood. But yeah, yeah, I guess it's working. Yeah, so I think I'm gonna call this pretty well done here.